We are Afrotech. This is the team. This is Jess, Ryan, Martin, Scott and John.
This is the systems architecture diagram. It shows how the ROS PC is the hub of the solution and integrated with a MyRio, wide lens camera and an Arduino which controls the track robot.
To determine the visual error codes, we'll be comparing histograms of multiple images back to a baseline image to determine how long red light is detected for.
This is the setup showing an overhead camera feeding information to the ROS PC. This picture shows a depiction of the maze where the black lines represent borders or obstacles. The black tape in the middle needs to be added as another variable in our viz so that it can be ignored as an obstacle and so a true representation of the maze can be depicted.
We have been using OpenCV and the hue line transform to determine the edges of the maze. This information is then sent to ROS, and using the RViz simulator we can determine the route for the track. The information is sent and received to the track via Bluetooth.
As you can see, the ultrasonic sensors and movement servos hardware is integrated with the tri-track, which we can communicate with wirelessly. The robot is able to carry all component parts and power sources.
This is our current audio detection solution. We're using an external microphone module connected through an analog pin to a battery-powered MyRio. The MyRio is using an internal 1 MHz hardware clock to create a sampling rate of 3 kHz. On the left we can see two frequency domain graphs representing power within the recorded signal, and on the right is the time domain representation. A longer signal in the time domain produces a higher peak in the frequency domain. The amplitudes are recorded and compared, from which we infer the appropriate error code.
Our capture system is comprised of 3 collaborative servos and is capable of gripping and lifting the road droid, ensuring it stays horizontal at all times. This whole system is controlled by a human-operated wireless Xbox remote, as we believe this will be more precise and accurate compared to being fully autonomous.